Okay, here we go. Now, 1301 used to have two parts to it, and I actually split it up. So 1301 is just the forward and reverse of a motor. And 1302 is now concerned with that problem that I brought up at the end of the 1301 video. And that is that we have to wait for the start switch to re-engage. So we've actually incorporated that into this shop job 1302. And so you're going to find that the inputs are all going to be the same. And we still have the start and stop push button with the selector switch. We actually have added a light here. So we have this yellow pilot light, and that's going to be our wait indication. That's going to let the operator know that they have to wait before they can actually restart the motor. So the explanation down here says this shop job is just a continuation or extenuation of the previous forward reverse shop job. And we want to add in a wait function and a wait indication. So I'm going to go back to our setup here. And we're going to start with 1301. I'm going to come offline here. And the first thing I want to do is save this as 1302. And change my comment to 1302. Okay, and now we're just going to modify this program. And first we want to, I'm going to work our way from the bottom up. So we're going to kind of get our yellow light implementation set up, and that'll kind of help us design this out. So we're actually, again, sticking with my convention that we want all our outputs to be in order. If we come over here to our PLC assignment sheet, our address for our yellow light is right here. It is this output 0.0/0. Okay, so getting that in the proper order here is going to be, we want it to be above this. So I'm going to come here, I'm going to click on this, it's going to put a rung underneath it, and I'm going to have an output that's going to be that O:0.0/0. Okay, now this is just going to be our wait indication. Okay, and we're just going to call this wait. Okay, so that's going to be my yellow light. And much like we're using the lights here as holding circuits, we're going to use this light as our wait status. So we want to add a disabler in here on both of these that you're going to have to wait before you can command this thing to run. So I'm going to come here and put focus on my stop, and I'm going to say, as long as we're not in wait, you'll be able to start the motor. And of course down here as well, as long as we're not in wait, or wait is a 0, or the light is off. All three of those are correct statements. If the light is off, then you will be able to start the motor. Okay. So I'm going to scroll down here, and we have to define what this wait is. Okay. So the wait is basically going to be the period between when you stop the motor and when the 8 seconds is up, because we're going to say that the start switch re-engages within 8 seconds. Okay, we're just using that as a target. When we actually get into shop and can test these things, we can adjust the time so it fits your exact motor. Okay, so we're going to have a timer, because we need to time something for 8 seconds. And as long as the timer is not done, it is in the middle of a timing process. So there are 3 output bits for a timer. In fact, let's go ahead, we'll come down here and we'll implement the timer. Now for specific reasons that I will explain later, we always want our timers and our counters to be at the very bottom of our program. So I'm going to add a rung here, and I'm going to come over up here to this counter timer tab, and I'm going to select the time on delay, and this we want to select a timer register. Well, if we come over here and look in the the data files, we have timer registers, and the very first one is T4:0. And I want to actually put this address right here in the timer. So I'm just going to grab the T40 and just drag it over there. Okay. So I have a register assigned so that timer can have some place to store its information. So this is my motor timer, and this will be MTR-TMR. Okay. All right, so then it's going to ask what interval do you want, and we want to time in seconds, not tenths of seconds or hundreds of seconds. And then I said in the job sheet we want to have a duration of 8 seconds. And so now all we have to do is determine when we want this thing to time. Well, we want this to time when the motor is not running. And what tells us the status of the motor? I'm going to come back up here, and under my user tab, I want to select examine if open. If my status contacts are open, that means my motor is not running. And my status contacts are what? This MC underscore stat. Okay. And so if they're open, then this will have logical run continuity, and it will start timing. And when this is during its timing period is when we don't want to be able to do anything with our actual commanding our motor. So we have 3 output bits from this thing. We have the enable bit, we have the done bit, and we have the timer timing bit. So here, if I just put in my T40/TT, as long as my timer is timing, this yellow light will be on. So this timer timing bit will only be on for 8 seconds because that's the duration of our timer. And it'll only be timing when the motor is off. So this timer timing bit will be off for the initial 8 seconds of the motor being off. And during that 8-second time period, our light will be on. And of course, we've already set it up that as soon as our light comes on, we're disabling either direction. Okay, I'm going to go ahead and check this. I'm going to go ahead and download this. Okay, our yellow light comes on right away because our timer is timing because our motor is not running after download. So when you download, you do have to wait 8 seconds before you can start the motor. There's actually a workaround that we can examine in future lessons on how we can even keep that from happening. Okay, so right now we have a reverse direction selected, and the yellow light's not energized, so we don't have to wait. So I can go ahead and hit start here. Okay, so I made it to run, and we're running in reverse. That means both relays, if you see down here, that both relays are on. And of course I have my blue light over here, and my green light tells me that we're running. Okay, and so that's all good. So we're going to come down and we're going to watch the execution of the timer down here. I'm going to go ahead and hit stop. Now, if you notice, the timer is in the middle of its timing sequence, and my yellow light is on saying the timer is timing. So once I reach my preset of 8 seconds, my yellow light went out, and that will enable me to actually select a different direction. Or the same direction. I'll go to a different direction. Okay. And I have to wait for my timer to complete here. Okay, so now I've gone in a different direction. Now I'm going to hit stop, and I'm going to try changing directions, and it won't let me because it's waiting for that yellow light to come on. Now, once the yellow light has completed, then it actually begins timing or begins running in the opposite direction. Okay. So that is how to get that implemented for 1302, or if you have an older job sheet, 1301 Part 2. This has an inherent problem though. Right now I'm running in the reverse direction. If I hit stop and then I try to hit reverse again, it will not let me go in reverse until I wait for 8 seconds. Now, the only reason we should have to wait is if we have a direction change. If we hit reverse and then hit stop and hit reverse again, we should be able to start right away. And we're going to solve that in the next couple shop jobs. So I hope this helps, and we'll see you in the next lesson.